Welcome to Metrology lecture series. In the present video, we will discuss the definitions in limits, fits and the tolerances. Let assume that shaft and hole touch at the bottommost points and then complete tolerances will be considered on the top portion. So in the picture, it is observed that this is the shaft and this is the hole. Here assumed that shaft and hole touch at the bottommost portions and the complete tolerances will be considered on the top portion of the hole and shaft. So let's see the first definition. Nominal size or basic size. The nominal size of a dimension is the standard size of the part with reference to which limits of the part or variations determined. So in the picture it is the basic size. So next we have to see the terms shaft and the hole. The term shaft refers to not only to the diameter of a circular shaft but also to any external dimension of the component. In general, any external dimension of the component we are calling as the shaft. Similarly, the term hole refers to not only to the diameter of a circular hole but also to any internal dimension of the component. In general, any internal dimension of the component we are calling as the hole. So the next term is the actual size. So this is the measured size. So actual size is the measured size. So next one is the zero line. It is a straight line drawn horizontally to represent the basic size. So let's see in the schematically. So here basic size is represented by a horizontal line. The line we are calling as the zero line. In the graphical representation of the limits and fits, all the deviations are shown with respect to this zero line or the bottom line. So in general, positive deviations are shown above the line and the negative deviations are shown below this line. So next we have to see the term deviation. Deviation is the algebraic difference between the size and the corresponding basic size. So deviation means the differences between the actual size. It may be the maximum size or maybe the minimum size with respect to the basic size we are calling as the deviation. So next we have to discuss the different types of the deviations. First we have to see for the upper deviation. Upper deviation is the algebraic difference between the upper limit of the size and the corresponding basic size. So here we have to observe that one the upper deviation for the hole. First we have to see upper deviation for the hole. Upper limit of the hole minus basic size we are calling as the upper deviation of the hole. Similarly we have to observe for the shaft also. Upper limit of the shaft minus basic size we are calling as the upper deviation of the shaft. And this upper deviation is a positive quantity when the maximum limit of the size is greater than the basic size, and this upper deviation is a negative quantity when the upper limit of the size is less than the basic size. So as shown in the figure. So let's consider basic size is the 25. And let's consider the maximum limit of the hole is 25.5. Similarly, we have to consider the maximum limit of the shaft is 24.5. Now upper deviation is the differences between the upper limit to basic size. So for the hole it will become upper deviation is the plus 0.5. Similarly for the shaft upper deviation is the basic size is the 25 minus upper limit of the shaft is 24.5. So it is the minus 0.5. So positive and negative quantity of the upper deviation is depend upon the upper limit of the size. If it is the upper limit is greater than the basic size, it is the positive quantity, and the upper limit of the size is less than the basic size, it is the negative quantity. And in general, upper deviation is denoted by ES, capital letter ES for the hole and small letter ES for the shaft. So remember, always you have to represent the capital letters for the hole and small letters for the shaft. So for the upper deviation, we are using the ES. So next we have to look for the lower deviation. So lower deviation is the algebraic difference between the lower limit of the size and corresponding basic size. So in the schematically you have to observe that one so here, so lower deviation is, let's consider for the hole. So lower limit of the hole minus basic size, it is we are calling as the lower deviation of the hole. Similarly, lower deviation for the shaft is lower limit of the shaft minus corresponding basic size. It is we are calling as the lower deviation of the shaft. Similarly, here also positive or negative quantity of the lower deviation is depend upon the size with respect to the basic size. So lower deviation is a positive quantity when the maximum limit of the size is greater than the basic size, and it is a negative quantity when the lower size of the, so lower limit of the size is less than the basic size, and it is denoted by capital letters EI for the hole and small letters EI for the shaft. Next we will discuss the relation of deviation with the tolerance. In general, tolerance is represented by the IT. So now we have to see the relationship between the tolerance and the deviation. So in the schematic you have to observe that here. So this is the tolerance for the hole and this is the tolerance for the shaft. And we know that one the tolerance is the differences between the upper limit and the lower limit. So now we have to see the relationship between this tolerance with respect to the deviations. First I have to look for the hole. So this is the tolerance zone and this is the upper deviation and this is the lower deviation. So this is the upper deviation, the difference between the upper limit and the basic size, and similarly this is the lower deviation, the difference between the lower limit and the basic size, and this is the tolerance. How we will get the tolerance? Upper deviation minus lower deviation we are calling as the tolerance. So the relationship between the tolerance and the deviations are the tolerance equal to upper deviation minus lower deviation. So first we have to see the relation for the tolerance and the deviations. We know tolerance equal to the IT equal to upper deviation minus lower deviation. So we know that when the upper deviation is represented by the ES and lower deviation is represented by the EI. And for the shaft we are using the smaller letters, and for the hole we are using the capital letters. So IT equal to upper deviation ES minus lower deviation EI. So from this equation we can be written as ES equal to EI plus IT. Similarly for the hole, IT equal to ES, capital letter ES minus EI, then ES equal to EI plus IT. So next we have to see the fundamental deviation. Fundamental deviation is that one of the two deviations which is the nearest to the zero line for the either hole or a shaft. So let's see the what do you mean by fundamental deviation in the schematically. So here this is the tolerance zone. So for the hole, and this is the upper deviation for the hole. So upper deviation for the hole, and this is the lower deviation for the hole. So what do you mean by fundamental deviation? Among the upper deviation or the lower deviation, which is the nearest to the zero line. So for this one, upper deviation of the hole and the lower deviation of the hole. So lower deviation of the hole is nearest to the basic size. So lower deviation of the hole is the fundamental deviation. Similarly, we have to look for the fundamental deviation for the shaft. So here, so this is the lower deviation for the shaft, and this is the upper deviation for the shaft. So among these two deviation, here upper deviation for the shaft is near to the zero line, then upper deviation of the shaft we are calling as the fundamental deviation. And fundamental deviation fixes the position of the tolerance zone in relation to the zero line. It is represented in the schematically in the figure. So next, the fundamental deviation for the hole is denoted by the capital letters A, B, C up to the ZC. And similarly, fundamental deviation for the shaft is denoted by the smaller letters A, B, C up to the ZC. So next we have to look for the basic shaft and the basic hole. Basic shaft is the shaft whose upper deviation is 0, and the upper limit of the basic shaft is the same as the basic size, and it is denoted by the smaller letter H. So let's see for the basic shaft. So this is for the shaft. So the definition is upper deviation is 0, and this is the upper deviation. So when it is the 0 value mean, so maximum limit of the shaft equal to the basic size. So it is only given here. So basic shaft is the whose upper deviation value, this is the upper deviation value is the 0, and upper limit of the basic shaft is the same as the basic size, and it is represented by the smaller letter H. Similarly, you have to look for the basic hole. So here in the basic hole, so this is the lower deviation of the hole, and this is the upper deviation of the hole. So what do you mean by basic hole? Basic hole is whose lower deviation is 0. So this lower deviation is 0. When the lower deviation is the 0, then lower limit of the hole equal to the basic size. So basic hole is that hole whose lower deviation is 0. Its lower limit is same as the basic size, and it is denoted by capital letter H. So next we have to discuss about the tolerance zone. So tolerance zone is bounded by the two limits of size of a part in the graphical representation of the tolerance zone. So this is the tolerance zone, and it is denoted by the magnitude and by its position related to the zero line. So next, tolerance grade. The tolerance grade is an indication of degree of accuracy of manufacture, and it is denoted by the letters IT followed by number. So where the IT stands for the international tolerance grade, and these tolerance grades are the IT0, so IT1 up to the IT18. So larger number will give the large amount of the tolerances. So this is the schematic you have to observe. So this is the tolerance zone for the hole, and similarly, so this is the tolerance zone for the shaft. These tolerance grades are the standard tolerances, and the numerical values have been determined in the terms of the tolerance factor small I. Small I is represent the tolerance factor. And in general, small I is expressed as the, so in the microns, 0.45 into cube root of capital D plus 0.001 into capital D. So please remember this formula. So I equal to, I is the tolerance factor and I is always expressed in the microns, and I equal to 0.45 into cube root of D plus 0.001 into capital D. Here capital D is the geometric mean of the lower and upper diameters of a particular diameter step in which diameter lies. In general, capital D, so diameter of the step is representing in the mm. So next we have to see these ranges of the capital D. So the various diameter steps are the generally 1 to 3 and 3 to 6, 6 to 10 and 10 to 18, 18 to 30, 30 to 50, 50 to 80, 80 to 120, 120 to 180, 180 to 250, 250 to 315, 315 to 400. So this is the ranges for the step diameter. So for example, if the shaft diameter is given the 25 mean, don't take the D equal to the 25. So it is the geometrical mean root to D of the in the range 18 to 30. So 18 into 30 we have to consider. So if it is the given D equal to the 25, 26, 27 up to in this range 18 to 30, within this range you mean you have to use, so D equal to root of 18 into 30. Similarly, if it is given the capital D equal to 32 mean, you have to consider root of 30 into 50. Don't take the directly D value. Here you have to use the geometrical mean diameter. And also have to remember that at least these ranges 10 to 18 and 18 to 30, 30, 50, 50, 80 and 80 to 120. In general, at least we have to remember these ranges. So next we have to look for the relative magnitude of each grade is given below for the basic size up to and including the 500 mm. So here different grades are there. So IT5, IT6, IT7 up to the IT18, and these values are the 7i, 10i, 16i, 25i, 40i, 64i, 100i, 160i, 250i, 400i, 640i, 1000i, 1600i and 2500i. So you have to remember these values. So respect to the grade, its values it will be changes. At least you should have to remember. In general it will be given IT7, IT8 and up to the IT12. At least these two you have to remember. So depend upon the tolerance grade you have to use the values you have to use.